Thanks for your patience, everyone. A very good morning, good afternoon, good evening to everyone for joining us from different locations. Welcome to the webinar. My name is Tanmay, and I'm part of the developer community team. Today we have Temenos experts Sundar and Babu, and they will introduce the Temenos Microservices Framework, covering the workings of the distributed architecture and its security aspects. They will also be talking about the different Temenos microservices that are available today and their corresponding APIs. So if this is the first time you're joining this webinar, there are a few things to note. Make sure you use the Q&A panel for your questions. Do not use the chat window. We have experts monitoring the Q&A panel, so post your questions over there. We are also recording this webinar, so it will be available later on Base Camp as a resource. So if you see your friends or colleagues not joining today, you can share it with them later. We will also be running a couple of polls during the webinar, so make sure you participate and make this entire event more fun. Now let me invite Sundar and Babu to take over. Babu, over to you. Thank you.
Yes, thank you. Can you allow me to share the screen? Yeah. Thank you. Can you hear me, Sundar, clearly?
Yep, I can hear you.
Okay. Yeah, hi. Welcome once again, everybody. So myself and Sundar will go through the session today, and we'll be the main presenters. And we'll have some help from the organizers to run through some of the polls that we have designed for this session. In terms of the topics that we're going to talk about, it's mainly, we have structured into three parts. Firstly, we would like to do a quick recap of where we stand today in terms of the Temenos, what we call as a Temenos value chain architecture. So we have moved on from a traditional front to back architecture to a value chain architecture since the time we introduced the concept of infinity. So we'll do a quick recap of that, and also a bit into the enterprise architecture and how does the latest runtime architecture looks like from a platform and deployment perspective. And then we'll move into the topic of the day for the session, which is about the distributed architecture stroke microservices architecture. And within that, we will quickly explain why we are doing this, plus what are the challenges that we'll have to deal with as a vendor when we talk about distributed architecture, and ultimately what is our response to that. We will also share with you the key frameworks, let's call it, for lack of a better word, those 5 frameworks that you see in this particular agenda slide. So we'll have a quick view on what they are and explain how do they actually work together to deliver that particular distributed architecture. And we'll do a quick summary, one slide, followed by any Q&A in the end. But as we said earlier, please start posting your questions as and when you see a slide or a topic that we present. Okay, let's move on. And before we go into the very first slide on this topic, let's do a very quick poll. This is to help us understand what kind of audience profile that we have within the audience in this session. So just spend a couple of seconds to quickly answer your responsibility in terms of where what you do in your organization, what's your job is, line of job is, and what's your area of specialization, and so on. Yeah, so just quickly answer them. We'll just pause for 10-15 seconds before we continue. Okay, so we have the results now, and I think we have probably the best audience for this session. So majority of you are architects, technicals, and developers, which is a fantastic audience profile for this session. And thank you so much once again for joining the session. So let's continue the slides. Yeah. So what happens with the Temenos value chain architecture? So let's break that down into different pieces as we have structured it. So starting with the first piece, manufacturing piece. I think this is probably you're very familiar. So this is where we help the banks to define the different banking products that they want to have in their catalog. This is where they set up the products. This is where they service the products. And it's basically a very flexible and a strong modular platform, yeah, from a manufacturing standpoint. And what this also means is that all the functions and features are fully exposed by APIs, and we have a very flexible design tool available for this particular platform. So you could expose all the functions and features in the form of RESTful APIs. At the same time, apply the RPA kind of an AI platform in order to automate any of those long-running processes or manual processes that in a given business that happens. Yeah. So RPA is also one of the key capability within the manufacturing platform. Moving on, distribution platform. This is fairly new and a recent addition to the value chain architecture. So we introduced when we announced our Infinity strategy. So within the distribution, what does it really do? So this helps the bank to really set up customer-focused, customer-centric distribution services, yeah, around all the products and services that you have set up, that they have set up in the manufacturing platform. And it's not just to the internal channels; it could also be exposed to the external parties and partner networks and so on. You're probably also reading from the market that this is one of the most disrupted area, and otherwise called as fintech space. So this is a very, very important subject for banks. And once again, all of those functions and features and services that we have set up here in this platform are exposed via APIs for the different consumers. And because we are talking about customer service here in this space, you definitely need a data-centric platform supported by engines like XI to further enrich the end customer experience. Yeah. And then the channels, of course, we are all familiar. So all the banks today, they offer their services via different channels in an omni-channel way. Yeah? So our distribution platform helps the bank to distribute any of the services you define in the distribution platform across multiple channels, across multiple devices. Yeah. And the smart data lake, this is again a very important proposition for banks today to really understand how do they further understand what's going on within the distribution platform and manufacturing platform. How do they collect the most important relevant data and apply the right metrics to further enrich the end customer experience. Yeah. And then followed by the one you see on the right side, which are the key NFR attributes, as we call it. And as you know, banking is one of the most stringent and the most secured industry and domain from a technical architecture standpoint. So you really need those key NFR attributes in your architecture, which is what we support in our what we call a Temenos value chain architecture. And one of the important reasons why we have designed our architecture in this way is mainly driven by the open banking. So that actually split, as we always say, the whole architecture into two pieces on the distribution side and the manufacturing side. And this also means with this segregation, very clear segregation, in fact, we could now support more business models that the banks are looking at, the business models that fintechs are looking at. But ultimately, this architecture is to really help the bank to deliver an exceptional customer service, yeah, or experience. Moving on. So what you saw earlier is more of a conceptual view, yeah. So now let's understand what happens from a product standpoint, yeah. So as you see, we are right now grouping our products into 4 different areas: distribution, manufacturing, data lake, and risk and compliance. So all of our modules and microservices and containers, they all come under this 4 key grouping or classification. Yeah. So what it means, each of them comes with their own set of microservices. Some of them are shared, some are platform microservices. We will see a bit of that a little later in the slide, but this is just to give you a product-centric view of that value chain architecture. Yeah. And before we move on to the following slides, let's just very quickly do poll number 2. And this is again to understand a bit of the audience level of understanding of the subject. So how much do you really know about microservices? We could understand this is a little bit of difficulty for Temenosians to respond, probably because you're here to actually learn more about it. But wherever you stand in this journey of knowledge, just respond based on that. And in a couple of seconds, we will see the results before we move on to the next slide. Okay, so now we could see the results, hopefully. So I think this is a fantastic state, right? I mean, everybody is actually hearing about it. It's not that it's not being spoken at all in a situation. Most of us are hearing about microservices. This is actually becoming an important topic within every conversation that we are having, at least in our experience. It's also very good to see that 20% of the audience are actually already working on it at the moment. Yeah. So thank you for the response once again. So let's move on to the next slide. So this particular slide should give you an idea of, okay, from an enterprise standpoint, from an enterprise architect standpoint, how our architecture should be actually understood or interpreted. Yeah. And so far we took the segregation of distribution and manufacturing segregation, whereas this time we are taking a slightly different approach because we are looking at it from an enterprise architect perspective. So we are segregating the products into from an API standpoint. So which are the APIs or which are the products that's going to look into the get and query type of throughputs, and which are the microservices and the products and modules that are going to look into put and post kind of APIs. Yeah. So that's a split you see. And you could see that there are different terminologies being used in terms of manufacturing, shared, enterprise, and so on. We'll have a explanation a little later, but this is again to set the context that this is how the Temenos architecture should be seen from an enterprise architect standpoint. And you also noticed we have included the concept of containers, microservices, data lake within this architecture. Yeah. And you also probably notice that we are talking about event store, event framework, which is again becoming a very, very important topic within our capability in the architecture. Again, one of the key pillars of our distributed architecture story, which we'll see in a while. Yeah. Moving on, the runtime architecture view. Again, this is from a deployment standpoint. So how do we take the Temenos software and actually run it in a given cloud service provider, or it could be a private cloud, public cloud, or it could be a typical on-prem infra, but with a cloud-like option. So we are just giving you a very agnostic view of how our software can be taken and run it in different fashion, such as public cluster. So all of your UIs and user-facing or partner ecosystem-facing APIs, they all run within a public cluster. And we have a couple of options here to run in a containerized mode. Some of them, they can be run in a serverless mode and so on. Followed by the private cluster. Again, we have a couple of deployment options in the form of running them in a containerized mode versus some of them in serverless mode. Followed by some of the important shared services, which are entirely just run as a serverless deployment. Yeah. Again, you notice the event store and event stream here, which is again becoming a very important capability within the architecture. And on the database, you also see we provide now multiple database deployment options. So for a given container or microservice, so there is a choice between an SQL and NoSQL, and within SQL, we have different modes of deployment, such as JSON-based or XML-based and so on. Yeah. So with this context of where we stand on the architecture, how can we see the architecture from an enterprise standpoint and runtime standpoint, let's quickly go into the topic for the day, which is the distributed architecture. Yeah. So we really have to start with this question of why is that we are really doing it. Yeah. So I think this is very, very clear that in a given cloud scenario, in a given disruption that's happening in the market, banks are really looking forward for a way to really quickly react to all of those business challenges that they're facing today. Yeah. So what it really means is that they have to really look at the entire architecture into multiple smaller pieces or multiple independent pieces that are loosely coupled with each other. So that's one of the main reasons why we'll have to go into this direction of breaking our architecture and making them to be more distributed on microservices. So the first is to be able to independently, develop the microservice and to be able to deploy them, maintain them, upgrade them, everything in an independent way at the same time in a loosely coupled manner. Yeah. What it also means is that it allows the bank to only scale up or scale to zero in that particular given business domain or a microservice. So it's not about scaling your entire business architecture to a given context. So you only scale which is the component that you want to scale. Yeah. And also the third point about why you want to do this, which is about reducing the risk for the banks. This is probably one of the most important reasons why banks are extremely interested and focused in getting this right. Because with this microservice architecture, they can really focus and also isolate where the areas of issues are and where the areas of risks are in a given architecture. And with this independent loosely coupled architecture, they can actually focus and isolate any of those risk areas they identify. Followed by fungibility. This is an important area because we should allow the banks to really pick and choose what kind of services they want to run in which platform they want to run, and how do they want to really replace some of them over a period of time. They could use one particular service for 6 months and then replace it with another service for the next 1 year and so on. So the fungibility is becoming a very important area when it comes to distributed architecture and why the banks wants to do it. Followed by efficiencies. If you put all of those first four together, yeah. So what you're ultimately arriving at is to have maximum efficiency for banks, because today they really are stuck with a set of systems, large systems. They're not able to move forward and they're not able to upgrade faster. So with this kind of independence architecture, they are able to achieve a much higher efficiency. Yeah. And then followed by our Temenos Microservices architecture principle. And this is sort of what we call as our internal, let's call it kind of a Bible to see what our working principles are whenever we talk about microservices, whenever we design and develop our microservices. So what are the key principles that we keep in our mind in our design? Starting with first, to make sure that that particular microservices is only focusing on a given banking domain for a given banking product. Yeah. Just quickly, for examples, CASA, deposits, lending, accounting. There are more such services that we have in the roadmap. But just to quickly pick up some examples, for example, deposits. So deposits microservices will only focus on, servicing the underlying deposit product catalog. Yeah, short-term deposits, long-term deposits, and so on. So our microservices, the first thing is to really decide what those domains are. And we have a very rich experience, so we can actually arrive at a very clear catalog of such microservices that maps to the underlying banking domains that are needed in a given bank. Yeah, that's number one. And we also are grouping our microservices into 5 different areas: distribution, manufacturing, shared, platform, and enterprise. Distribution, as you saw earlier, it's about making sure to help the banks to build a set of microservices to address their customer experience requirement, to address the distribution service requirement, and open banking kind of a requirement, the new business model kind of requirement, and so on. One such example I could think of is order management or payment order, or it could be holdings and so on, followed by manufacturing, which is what I quoted an example earlier, which is about deposits or lending, counting, fund management, and so on. Shared microservices, and this is again, after a long analysis, we have arrived at a decision that we think that there are a lot of microservices that can actually be shared across the different other microservices, such as distribution microservices and manufacturing microservices. So they come under the shared. Platform microservices are purely focused on delivering a technical capability. For example, event store, service orchestrator, traceability, they all come under this platform microservices. Yeah. Followed by enterprise microservices. There are, the moment, a couple of them identified, such as enterprise limits management, pricing, and also a product catalog and product hub. Yeah. And then one of the other key principles that are already part of the microservice architecture is to make sure that we only have one particular database for a given microservice. So deposits microservices will only have a set of data tables that only deals with the information that are relevant to that deposits microservice. Yeah. And again, going by the principles of microservice architecture, all of those microservices are completely hardened, and they can only be accessed by APIs and by no means else. Yeah. So we'll have to keep in our mind. This also brings our API first strategy very important. So anything that we design within the microservices in terms of functions and feature, they will be represented in the form of consumable RESTful APIs. And you could only access those functions and feature via those APIs and by no other means. Yeah. And we also give a couple of deployment options when it comes to clients taking our microservices and wants to run them in their architecture. Primarily, as I said earlier, two. One is a serverless, which is again one of the cutting edge services provided by the underlying cloud services platforms, such as Lambda functions and cloud functions. And also for other set of microservices, we support them in a containerized deployment. Sometimes in an on-prem scenario, if some of our clients wants to run some of our microservices, yes, we do support a Dockerized version for all of the microservices that we have identified. And one of the most common questions that everybody wants to really understand from a vendor like us is to understand, okay, so yes, Temenos has 4 to 5 platforms. So with the microservices architecture, how many is that? How many are the number of microservices going to be in the future state? Yeah. So this is where we really want to take a very balanced and in fact a very careful decision here to make sure that we don't really start introducing hundreds of microservices. So we are really handpicking what is that we want to do in the space. And that's where we like to call out the Goldilocks principle. So it's not too coarse, not too fine, but just right. All right, so that's with the that introduction of the architecture plus why we need to go into this microservice architecture plus the principles that we have in place today. We'll now go into the next poll, the last poll. Spend a few seconds here to answer that particular last poll, and then we'll continue the session. Yeah. Yes, Sundar, over to you.
Thank you. Thanks, Babu. Let's see. We'll give another 5 seconds before we see the poll results. So there it is. Okay, so that's not a surprise when we say lots of people are evaluating it because they've, I mean, it's consistent with the results of the earlier question where most of you said that you're still hearing about it. So it makes sense that you're still evaluating those microservices. Thanks for answering that question. So moving on to the next set of slides are to explain our distributed architecture. Sorry about that. And I wanted to start with this slide. we've seen that, okay, Babu established that Temenos has a loosely coupled event-driven distributed architecture. And he's also talked about why we wanted it. Now, this slide kind of gives you the high-level view of the challenges that we face in a distributed architecture and how we are addressing those challenges. Now, in a distributed architecture, the primary concerns are safety and security. And it is mainly to ensure how we ensure data integrity, how we ensure data security within that framework. And these are some of the challenges around distributed architecture. This is a high-level view, and I will be drilling down into each one of them, and we will see how we have worked on those challenges. Starting with event atomicity, we know that in a event-driven architecture, it is important to guarantee that events are raised on completion of a transaction. In fact, we need to guarantee that those events are raised only after the transaction is complete. And to implement that, we have implemented a standard inbox-outbox pattern, which is part of our microservice framework that Babu has just explained. Now, this inbox-outbox pattern ensures events are atomic with the business transactions, and events are idempotent. That is, the consumer may raise duplicate events. The service validates those events and processes them only once. We'll see how this is done, actually. Now, when we move to the distributed ecosystem, you can assume that each service will need to do multiple callouts to get access to external data. Now, we want to limit the time we are exposed to external unknown SLAs within the transaction boundary. So to overcome this, we have introduced this pattern of data composition, wherein if an API call needs external data, it could go and fetch that data before it makes a call into the record keeping system to process it. So this pattern ensures better response times and reduces the window where we hold the logs on the artifacts. So this pattern is actually solving and minimizing the external calls we make to downstream systems. Very closely related to that is the service orchestration. Now, again, this is a pattern which ties everything together. What the service orchestrator solves is the following question. So in a distributed architecture where we have multiple services having their own technical transactions across a single business transaction, we need something that ensures the data integrity, especially when we are dealing with multiple different technical stacks within a single business transactions. Now, the moment we talk about distributed architecture, everybody will think about two-phase commits. We're going to talk why that is not an option in this case. So the answer to this, getting data integrity across a distributed transaction is the service orchestrator pattern. This is also refers to a saga orchestrator. We'll come into that when we drill down into this pattern. Moving on, we also needed a single source of truth for all commands and events that hits the solution. So we need to know what has happened within that ecosystem. And the answer to that is the event store pattern. The event store guarantees the ordering and uniqueness of the events. It allows replay and catch up of events, and also provides a sort of immutable view of history of all the events that has happened within that distributed ecosystem. And if you look at it, it also helps to, it also helps in a way that when you're taking on a new service, the data take on for that new service is just replaying the transactions from the event store. Finally, we need to have a security framework which spans across all the software real estate in the distributed ecosystem. And not just that, it has to be, following an industry standard and making sure that it can offer the same coarse and fine-grained access control that we have in the Temenos ecosystem. So our security framework does just that. see if I can click. Okay, yeah, that changes. So let's drill down to each of those components that we were talking about, each of those challenges and each of those, as Babu said, frameworks. So as I said, one of the key issues of a distributed architecture is the event atomicity, and also to make sure that we process the event once and we also deliver the results or the event, which is the result of that particular process only once. So to ensure at least once delivery and the idempotency of all the messages within the event-driven architecture of Temenos, we employ a combination of transactional outbox with a similar implementation of a transactional inbox. Now, for people who know about the Temenos architecture, transactional outbox is very similar to the integration framework. Now, how does this work? So if you look at let me just wait till the slide moves. So if you look at this architecture, and if you look at the numbers given, so I've just marked down the numbers 1 to 5. So the first step is the message coming into the microservice. Now the microservice gets the message either by subscribing to a particular topic. So in case of serverless, it gets the message pushed to it, or in case of if it's implemented as a Docker, it consumes that message. Now the service inside the microservice, the service inside the microservice will check its inbox and see if the ID that is received in the message is unique. If it finds the ID within its database, it will ignore the message, saying that it has already processed it and it is a duplicate. And this ensures the idempotency. Otherwise, the service continues to the next step, the step number 2. Now, where the processing of the message happens. And while processing the message, any resultant state is written along with the updates, the inbox and outbox record within the same database transaction. Now, this ensures that in case the state change fails, the message will be consumed again because it is not written to the inbox table. So the ID is not there. So the system will again try to process it. Now, once the event state is changed, the outbox record is written with a pending status. And it contains the outgoing event message details. So either within the same process, or if in case of failure through an asynchronous watcher, the outbox message is read and it publishes that process. So that triggers the publishing of the process, which is what I've shown as 4 and 5 actually. So it updates the outbox saying that I've sent the message, and it will also update the topic with outbox message. So the message will either be put into the queue of the event store. I'm going to talk about the event store, or it will be published directly to the downstream system. So once the message is delivered, the outbox records the event as a sent status. So this indicates that the message has been successfully published and no further attempt will be made to publish that event again. Now, it is possible that between sending the message and writing the status, that there could be some error that has happened and the message is not written. So in that case, there is a retry that happens to the message, and it is pushed to the respective topic. So that's how the inbox and outbox pattern works. Now, moving on to data composition. Now, this is something that for people who follow the Temenos architecture, this is something that was already introduced within the Temenos API framework, also codenamed as Iris R18. We used to call that as a master data access layer. So we introduced this data composition pattern in order to, as I said before, to limit the time we expose, or time we are exposed to an external unknown SLA. So when we have an API call, and this API call needs external data, we could go and fetch that data and make sure that the data is enriched before we make call into the record keeping systems. So for example, if you look at this, this very simple representation. So if you have a request, the request is anything that you get from the external system. You have a very basic detail of the in the request. The data composition part will be the enrichment of that data. So what do you need actually for this request to be processed by this service? So the data can be external contents like the customer details, the product details, account details, etc., etc. So there is a composer logic in the API framework which makes those call out, collect those external data, enrich the request, and pass that enriched request to the service to process it. Let us look at it from an example point of view. So if you look at this, so you for a let's say it's a payment request, and for that payment request you get a ordering customer and a debit account ID, which the payment processing microservice will not be aware of. So it has to reach out to understand who the customer is, or very basic detail of whether the customer exists. So it will get back the let's say the first and last name of the customer to make sure that this customer exists in the distributed ecosystem. And also on the account details, it needs to know whether the account has sufficient balance and it has no posting restriction on it. Very, very vague example. But the data composer enriches this request and sends it to the underlying service. So this pattern makes sure that the number of calls made, the callouts made by the downstream system is reduced, and we also don't, hold the log on the specific API call for a long time. Going forward, we come to the service orchestrator. A very important challenge that this solves is the data integrity. Now, in a distributed world, in a microservice world, it is common that the transaction takes a longer time in its path to completion. Now, this is because the path involves multiple databases and needs to communicate with multiple services. Now, this makes the landscape more complex and difficult to keep the consistency of data. Local asset transactions won't help if the communication happens between separate services with multiple databases. Now, the question that the service orchestrator answers is, how do we maintain that data integrity? Now, there are several ways that has been approached for historically to solve this, like two-phase commits, but I'll come to that. But let's take it a step backwards. Now, let's take an example of this. For a standard payment initiation, let's say the payment processing, the payment process should trigger, let's say, 3 actions actually. So like creating a payment order, making sure that you reserve the funds, and making sure that you do the accounting, moving the funds and marking the funds as moved. Now, in a traditional monolith application, all these transactions are written in a single code base. All these actions actually. So we know for which payment we are doing the funds reservation, for which payment we are moving the money, and for which payment we are actually posting the accounting. Now, when we look at this from a distributed architecture where the payment reservation is a separate microservice, the accounting is a separate microservice, then we need to have another way of doing this. So traditionally, the two-phase commit might be a solution, but there is a bit of issue with the two-phase commits, both conceptually and theoretically. That's because two-phase commits, as I've written here, becomes bulky. It gets the network flooded. It does have a single point of failure, and we need to design the application to handle extended log durations. And also, one of the other things that we noticed was this does not have a mechanism to roll back the actions that it has done within a long-running action. And also, one of the main issues we faced was no SQL databases and graph databases do not support two-phase commits. So for that reason, we end up in a situation where we cannot use two-phase commits. So what are our options? Our option was to use something like a service orchestrator. A service orchestrator is also referred to as Saga patterns or Saga orchestrator. Saga Orchestrator consists of independent set of operations, which altogether forms one atomic action. Now, this service orchestrator, as you will be seeing, is well suited for our banking domain, because that's one of the issues that we are trying to solve here, banking transactions. Because fundamentally, this is how banking works. Let's look at this. So for a service orchestrator to work, each operations within that transaction needs to have a corresponding compensating action, operation. When I say compensating operations, in simple terms, it is an undo operation that is invoked in case of failure of a subsequent operation or command. In terms of messaging, it's not an actual undo, but it's it's not an undo per se, but it is a compensating action. Fundamentally, this is how transact was written. And when decomposing the transact, we and the Temenos solution in a distributed architecture, we need to follow the same integrity. Perhaps we don't expose those compensating actions as explicitly as they are, but the functionality does exist in transact to say that if in case something doesn't happen, it knows how to roll back that particular action. So essentially, when we perform an action, let's say operation 1, it then says, okay, I've done my action, and it performs, it triggers the subsequent action. And in a happy path, all the operations gets triggered, gets completed, and then the transaction is done. But what happens when there is an issue? So when there is an issue, we have the notion of compensating action. So most of the time, in order to compensate, let's say, a failure of operation 1, what we do is pretty much reverse that operation. But in this case, let's take this example where operation 3 fails. The undo for operation 1 might be different. Now, these are exceptional cases, and we have catered for that in our service orchestrator. But as I said, this is something of an exception. So basically, the service orchestrator is not a, we don't want to replicate the business logic within the service orchestrator. It is what we call as a dump pipe. It understands how to execute commands in sequence. It understands what should happen if there is a failure, how to go and undo those actions. Now, taking that to our example, where we have these 3 actions of reserving a fund, moving the money, and marking that fund as used. And if you take a typical transact example, and let's say we have done the reservation of fund, we have, and while we are doing the moving of funds, there is a failure. The system goes and says, okay, we have to undo the reserve funds. Now, how does all these events gets orchestrated? How does the commands go from one service to another? Before we look at that, we have to look at the next component, which is the event store. Now, event store again is a microservice. As Babu was saying, this is part of our platform microservice, and the purpose of this is to hold all the events raised by other microservices or applications in our said distributed architecture. Now you can say that it's a central audit for all the events raised and processed, and it is also a view of every event that has happened in that particular ecosystem. Now, event store also is responsible for routing of the respective routing of the message to the respective microservices or to the respective destination to get it processed. So, for example, in case of a payment order that we just saw, funds reservation, it has to invoke that particular service to say you have to do the fund reservation. Now, when we say routing, it doesn't mean that we have the logic written in here, we have codes written in here to do the routing. It's basically that it uses a namespace and the named topics to do those routing. I think when we talk about events, I think it's best to know about the 3 types of events that we consider in this distributed architecture. So there are command events. Command events are the request for a business events to be done. Business events, this is the result of a command. or a user-initiated transaction. And data event. A data event is an event that has been turned into an insert in some kind of a reporting model. So how does this work in action? So if you see here, and again, one of the thing I want to point out is that event store is not event sourcing. It's slightly different. Event sourcing is where we only persist the commands, but here we still change the state of the underlying business object. So with event store, we record all types of events, and we also have included API calls going forward. So the event store is basically an inbox outbox routing of commands and events. As I said, routing is not by logic, actually, it is by namespace and according to the name of the queue or topic. So what it provides is replay of events and catch up. It ensures ordering and uniqueness of events, and it gives a history of everything that has happened. And because it has the history, it allows to replay and catch up of the events. So the event store persists both commands and events, and we also take care of queries. That's what I meant when I said API calls are also recorded in this. So how does all of these event store or service orchestration come into play? So this is how. So if you look at this, this is the same example of the payment service, which is trying to complete a payment transaction. Now, if you look at the arrows, the gray arrows there, it does not indicate that we are actually calling out from a microservice to another microservice. It's not an implicit call. It is for you to assume that all these arrows are actually in fact going through the event store and then getting invoked within the microservice. So let's say a payment service invokes a payment initiation. And what happens is this payment initiation creates a command event, which says that these three commands are to be executed by the application, by the ecosystem. So it knows that okay, for this particular payment service to complete, you have to do reservation of funds, you have to move the money, you have to mark the funds as used. Now this goes to the event store, and then the event store pushes that. Again, you can visualize that the event store also has an inbox and outbox, and the inbox checks whether this is a duplicate command. If it is not, it writes it, and then once it pushes it to the outbox, which then pushes it to the relevant topic. And this topic is what the service orchestrator will be listening to, and the service orchestrator receives the command, and again understands that it has to do the three sequence of actions, and it pushes that again via the event store, pushes it to the funds reservation topic, and then the funds reservation. You can see that the funds reservation will get that request within the inbox, checks whether the message is duplicate or not, checks whether the message is complete, and make sure that it does the processing. And the funds microservice then raises its own business event. So within that microservice, we have the logic to for it to say what are the events that it will raise. So it raises a first class business event here, and this business event. So it does do two things here. One is once it completes its action, it sends a message back. Again, the underlying framework sends a message back saying I've completed the command, and this is sent back to the service orchestrator. Now again, it is sent via the event store. Just the arrows just says that this is how it is done. And it also, as I said, it sends the business event to the event store saying, okay, this is the business event I'm raising after completing the transaction. So that's how the entire transaction happens right from the initiation to the completion of the transaction within a distributed architecture in the Temenos event-driven solution. Finally, and most importantly, we talk about the security framework. We have now implemented what we call as the Temenos authorization framework, also known as the authorization policy engine. Now, the authorization policy engine is it provides us a centralized authorization engine, and this controls how the policies are propagated towards towards the different microservices. So within the microservice, as Babu was saying, one of the components is the policy execution points. So we follow something called as other XACML framework for this. So this is the industry standard that we follow. And as per XACML, we have a clear distinction of how we separate the security definitions at design time and the executions at the runtime. So we have introduced a policy administration point as a separate user interface where you can administer the policies and you propagate them to the runtime. And at the runtime, at the execution, the service will check whether the particular user has the credential to use this service. And if it is, then it will start processing it. Otherwise, it will send back the error messages. So this provides a distributed way of administering access control in a distributed architecture. Now I'll pass the control to Babu now to summarize what we have just talked about. Babu, over to you.
Thank you. Yeah, thank you, Sundar. So this is the last slide, really, to summarize what we have been speaking so far. It also sort of presents sort of a complete view on the technology transition or transformation that we are doing. So from the left to the right. So yes, containers, microservices, AWS, Azure, GCP. I'm sure most of the audience are quite familiar. We could already support that. In addition to that, we are introducing more support for more cloud service provider, Ali Cloud, IBM Cloud, Oracle Cloud, we recently introduced. And we just announced the support for Anthos, and we also have more cloud service platform support coming up. But I think what I want to really highlight in this is that as part of our strategy in this transformation, a couple of things, right? One is to make sure we introduce more microservices within those 5 categories that we talked about. At the same time, make sure from a tiered architecture, we are really moving into a distributed architecture. What this means is that the banks can take our microservices and they could actually deploy them, not just in one cloud service provider, but it could be running on more than one deployment platform. Yeah, multi-cloud, on-prem plus one cloud, and different combination. And for this, essentially, you have to move to a much more stronger and deeper event-driven architecture. Yeah, so that's the journey we are going through, and hope the session today gave you a sort of a snapshot view of where we are, our architecture, the challenges that distributed architecture actually gives, and then how do we plan to address those challenges. Yeah. So with that, we'll quickly go into the Q&A. There's quite a lot of questions. So Sundar, we'll just go one by one. Yeah.
Yes, please.
Yeah. So queries will be processed from ODS DB or from Transact DB in the new architecture. So for the queries, which for us, primarily all the GET APIs, we have a dedicated set of serverless deployments identified. One quick example that I could code is the holdings, which is about giving a quick snapshot view of the customer holdings with the bank. So that's how we plan to do it. What's the difference between public cluster and private cluster? Public clusters are the one that are deployed in a container orchestration cluster that are exposed to the external world via internet and via firewalls and via the load balancers. Yeah. And the privates are the one that are purely internal to the organization. They are only accessed by the private public cluster. There is no other way you could plug with the existing microservices. Good question. So a set of microservices that are already available for our customers is already part of our published price list. So please get in touch with your respective account manager or your Temenos contact. You could get that list, and you could understand what each of those microservices are. Of course, as we said, there are more coming up as part of the roadmap. Does T24 support OpenShift? Yes, absolutely. From, I think if I remember, from February, March build this year, or you could say R20 AMR. Yes, we do support OpenShift, and we do have a reference architecture for OCP. Does Infinity Kony support OpenShift? I don't know the answer at the moment. Sundar, would you know the answer for that?
I think it does, but we'll have to get back on that. Khalid, do send us a message. We have our email addresses in the PowerPoint, so please do send us.
Okay, that's good. So we'll come back to that. Peter asking, explain a bit more on the different types of microservices. Unfortunately, we can't explain that in 10 seconds or in 1 minute. Peter will speak to you one-on-one on this, or perhaps publish a blog to explain what those 5 categories are and why we have those 5 categories. Yeah. How is provides history different than the allows replay? Can we redo the same event flow? Sundar, do you want to take that? It's about understanding.
Yeah, so I assume that this is how does it provide history and allows replay. So that's what I went through. So if you look at the event store, it kind of is the middleman between every transaction that happens. And the last slide that do you want to go back a bit? I still have control, right?
Yes, you do. Yeah.
Just a second. Sorry. So if we go back to the slide, and this is what I was emphasizing, that everything goes via the event stores, and so event store records that and has a log of everything that has happened, and that's why we say that it provides a history, and because it has that audit log, we can use that to replay that event as well. Okay, next question.
Okay, can the Temenos Microservice replace ESB to a certain extent? We don't see how they are related, but let us explain that in a Temenos Microservices implementation, there is no role for ESB. Ours is going to be so there will be 2 important integration capability that we allow. One is to allow to access the business services via a well-defined API catalog. Yeah, at the same time, emit a predefined event catalog. So those are the 2 capabilities we'll provide for every single microservices. So you will not need an ESB. It's ultimately the bank decision if they still want to use it for some of the use cases. Temenos has multiple products related to banking. I hope Microservices Framework applies to all Temenos products. Absolutely, it is right. But it's important we share with you guys that different products are on different maturity level when it comes to taking these frameworks. But absolutely yes to that question. Sundar, to you.
We'll go. I mean, yes. The answer was yes, but the next one is: will the event expire? Will the expired ones get automatically purged? No. That's one of the reasons why we are using a separate event store. So there's no expiry, and we make sure that we have statuses in that particular messages to understand whether the particular message is processed or not. So, and these are kept in that database, and it goes through the data cycles of getting archived, etc.
Go ahead, Sundar.
Peter is okay. The inbox outbox. Do you say that that in the inbox there is only the ID and the request in the inbox? Then the microservice will read the full data from the table event store, process, update it. Okay, so in effect, yes. So the ID is what we use to make sure the events are idempotent. And yes, the microservice will read, and so I didn't understand the next part of the questions, but yeah. So what happens is when the message is written to the outbox table.
Sundar, is that in the inbox, whether the particular microservices will have all the data that needs to process that particular transaction within the inbox itself, or it has to refer to the event store or some other store to know the request?
So it does have actually, and for what it doesn't have, as I said, the data composition will enrich that particular event. And when it writes to the outbox, it also contains all the details it needs to publish in that business event. That is part of the transaction. Okay, let me go on. What are the maximum namespace queues that can be created? Babu, do you understand this?
No, I
I
think
don't
it goes
think
back to.
there is a
Go ahead.
limitation on that,
Hmm.
on the namespace. So yeah, we don't have a limitation on that. Kiran, question. The business events referred in the event store are different from T24 transact business events. Well, as I said, the outbox is, you can compare it with the Temenos integration framework, and that is an example of a business event. So yes, you can compare it with the transact business event. Distributed transaction management is only applicable for microservice or T24 transact as well. In case of using IRIS R18 independently for T24 transact. Well, do you want to take that, Babu? Or okay,
Yeah,
let me
yeah,
see.
yeah. So I think, as we were explaining, right? So once you start to break that architecture into multiple pieces for a given business transaction, you may want to update more than one microservices. So that's where the distributed transaction management comes into place. So yes, it is applicable once we break down our products into multiple microservices. Number one, number two, within that, for a given business service, does it touch only one microservices or does it have to touch multiple microservices? Then we have to consider the distributed transaction management. Next one, when is this new microservices architecture expected to be available? As I said earlier, it's already available. Many of the microservices are in the price list already. So please speak to your relevant Temenos contact to take that. Yeah.
So that's again a
Again,
question on
same
microservice
question.
catalog. So I
Same
think we have
question.
answered that. Let's move to the
I
next one.
understand
I
both.
understand both manufacturing and distributing APIs are envisioned via microservice framework in this landscape. Where and how do you see quantum fabric's role?
Okay.
Um,
So I think this is a very good question. So we have an answer, thankfully. So when we talk about APIs in this architecture, we are naming them into two categories. One is the experience APIs. The second one is the enterprise API. So Fabric will deal with the experience APIs. From a manufacturing side, we will only deal with the enterprise APIs or system level APIs for all of those products you set up within the manufacturing platform. Will you share current recording this training somewhere? I think that was a decision. Yeah, you should be able to find them soon in the Base Camp. Does Temenos support OpenShift on IBM
we've
P8
answered that.
servers?
Okay.
No, on a particular server. I don't know if there is a correlation to these two, OpenShift on IBM. It's more of a question to the OpenShift rather than, because we deal with OpenShift and OpenShift has to deal with the underlying hardware. But we can park that and we'll have to come back to you, Mr. Khalid. Yeah. Jill, but if you're currently using T24 as core system, do you have out of the box APIs? Yes, absolutely.
Yes.
We have a very rich catalog. You should be able to find them in the same Basecamp or developer.temenos.com. Next one.
Event store is actions, right? Or it supports audit trail as well. What does replay mean? Can we re-execute the event? The replay, as I said, the replay is, if it is a command event, you can replay all the set of commands. The command event doesn't mean that it is one-to-one commands. You can have a set of commands. So as in my example, a payment initiation will contain multiple commands like, reserve a fund, do accounting, etc. It again, audit trail in the sense, if you talk about the SMS audit trail, that's not part of the event store. Event store contains the trail of all the events that has happened.
Okay, next one with the microservice. How does microservices change or affect the Infinity, and what is the difference between microservices and standard APIs? I think most of the time we see that people get confused between APIs and microservices. They think they can be used interchangeably, but it is not. Microservices is purely a style of architecture. It's a way to develop your software. And once you develop the microservices, you only access them via APIs. So APIs or a way to access your microservices. They are not a replacement for microservices. How does microservices change affect Infinity? Is Infinity or distribution side will also have a set of microservices to support the functionality for the distribution platform. Next one, with the microservice architecture, who takes charge of the user interface? Do we then build our own interface application? Very good question. So from a Temenos stack standpoint, we do have we do supply a set of UI, or in other terms, we like to call them as user agents. So Temenos stack will come with a set of pre-configured user agents. On top of that, we also believe the banks and the partners and fintechs and different partners will also develop their own UIs on top of the published API catalog from Temenos. Okay. How's the application
Nicholas,
logic transferred to the? Yeah, go ahead, Sundar. Yeah.
How's the application logic transferred to the microservice, especially for a put request? And what about local development? How's the application? So as we said, the framework, the microservice framework is so designed that it has the capability to understand the business. I mean, to host the business logic, and in fact, within the Temenos organization, we have the responsibility of delivering and creating a microservice given to a product vertical. So it's basically the business function, how they decompose it and create as a microservice. In terms of local developments, we do have a scope for that. In fact, one of the things I wanted to mention here was just like the extensibility, which is one of the features of Transact. We do have microservices available with extensible features, so we do support them as well. Can you explain in detail why we need one database for one microservice? Babu, you want to take that?
Yeah, sure. So can't explain in detail, first of all, but however, in principle, a given microservices for a particular business domain, let's say deposits or lending, so they need to host the set of data model related to that business domain. So they do need a database. However, principle, they can't share the database with other microservices, then you beat the whole purpose of microservice architecture. Yeah. So you only have one database for microservice so that you actually own the changes with respect to that particular microservice, and a change in the database doesn't impact the other microservices also. So that's one of the reasons why we need minimum one, and only that microservices can access that particular database. Where is these microservices are used exactly? It's used all over the architecture, as we explained earlier. Is this related to data event streaming?
Event streaming. So event streaming is part of the microservice framework. So as Babu was explaining, the microservice framework does contain an ingester component, which is basically the event streaming, which feeds out of the topics that the Kafka's topic where the event streaming happens, and it can also stream the event. So that's one of the event that we were talking about, data events. So data events can be emitted out of a service, and this would then in turn be an insert to another microservice or to a ODS actually. For failed transaction, how rollback in Temenos microservice is different than in other microservice products.
So there is no rollback as you explained, so there is only an undo transaction or a compensating transaction. We don't really roll back. We start to apply the compensating transactions in a microservices architecture for failed transactions. Okay, will T24 support MongoDB? Not for Transact, not for OLTP, but for the other microservices. I remember there was a support. I can't remember them right now.
We do support NoSQL databases. Yeah. If 5 categories can be deployed in different databases, how event store will get enriched information from business event if it involves microservices from different categories? Not sure I understand, but I think what you're saying is if there is different microservices using different databases, how will we get enrichment of information? So that's the data composer's job actually. So it understands where it has to get the messages from, and it understands it has a mapping layer to map the particular response from a particular service into the enriched request. Currently, we use Coney or UXP to write business logic for services. Okay, so microservice will reduce effort of writing business logic there. Exactly. Or is it only handling orchestration? So yeah, the idea is orchestration are the supporting or platform microservices. The actual, I mean, we as Babu was saying, we have different categories of microservices. So we do have manufacturing and distribution services, which does the capabilities, and distribution services distributes those capabilities. In terms of orchestration, it's orchestrating those different microservices in a distributed ecosystem. This is anything to do with integration or interaction framework. You can see that most of these, as I said, when you look at the inbox outbox, even the outbox is particular implementation of the integration framework. The interaction framework, you can see that in our APIs. So we have used those frameworks in this architecture as well. Do I need Temenos?
Temenos
Yeah.
Microservices Infinity and T24 Transact are used only. You will have to keep in mind Temenos Microservices is not a replacement for Infinity and Transact. Temenos Microservices is in the style of architecture to implement our Infinity and Transact products. So they are not different products, but just a way of implementing our offering around Infinity and Transact. Yeah. Next one is any log maintained for failed events?
Yes,
I assume so,
we do
right?
maintain that. Yeah, we do maintain logs for failed events as well, and that's where if the event fails, we do the retries, and that's one of the reasons. I couldn't go into detail of that. So that is one of the reasons why we use a service orchestrator, because we don't flood it with retries, but the service orchestrator understands how many number of retries it has to do, and then if it is not able to do that, it kind of posts a failure of that event, and does the compensating actions as well.
Okay, a question from Ms. Sundar. Do we have a catalog of experience APIs? The answer is yes. Please do refer to the Base Camp portal, developer portal. There was another question on the pricing model. Pricing model is different to the APIs. However, it is an important driving factor for our commercials. So please talk to your Temenos contact and understand a bit more on that. Next question is about the undo process. Sundar, do you want to take that?
Yeah, if there is a 3-step process and it fails at the 3rd step, will it undo and start to step 1? So as I said, yes. So it is not a straightforward undo as per se. It is a compensating action that will go back to the process 1 and say, okay, you do the compensating action for reverting back the process 1 transaction, and then the command is reposted again. As we said, the transaction is rolled back, and the inbox still has that transaction because inbox has not got the ID, so it will try to redo the transaction.
Okay, thank you. The last one, is this available in R20? And the answer is yes. Many of the microservices are already part of our R20 architecture. I assume this question is from our partner or client network, so please do speak to your Temenos contact, and they should be able to share the details. Yeah. So I think we are done. Anything else in there? Do you want to say before we really close?
Mary and Tanmay, do you?
Last question.
We
How long?
We exceeded the time actually, but
I see still around 80 people in the call, so that's quite good. Sundar, there's a last question. Maybe we'll close with that.
Okay. How long? Any timeout setup, system redos, the failed events. These are configurable actually in the service orchestrator.
Okay, that's cool. So that's it. So I think we are done. So we can close the Q&A.